Today we're going to talk about colligative properties. But first, I'd like you to explain what saturated, unsaturated, and supersaturated mean in relation to solutions, in relation to one another. You may need to use the internet to do this, so take a minute and let's talk about that. So the easy answer is if you look at a solubility chart at a given temperature, so let's look at potassium chloride at 50 degrees. If we have 20 grams per 100 grams of water of potassium chloride dissolved, so this is our potassium chloride line, it's unsaturated. If we go up to, and it's right on the line, so what is that? Probably 42 or something like that. That's saturated. If you have more dissolved than that, it is supersaturated. So unsaturated, on the line, saturated, above the line is supersaturated, and that's for any given temperature. Supersaturated solutions, you can't make them by dissolving potassium chloride at 50 degrees Celsius. If you do that, it will get to the saturation point and go no farther. But if you heat it up to something like 100 degrees Celsius and you dissolve as much potassium chloride as will dissolve there and then cool it back down, it will be supersaturated. So again, to review definition of electrolytes and non-electrolytes, an electrolyte is a substance whose aqueous solution conducts an electric current, and non-electrolyte is a substance whose aqueous solution does not conduct an electric current. And generally this has to do with either separating into ions or not separating into ions. So we use an ohm meter to measure the flow of electrons through a solution, and this will tell us if it's an electrolyte or a non-electrolyte solution based on what the reading is. If it measures a current, the bulb glows, then the solution conducts, and you have an electrolyte solution. If it doesn't, it's a non-conducting or non-electrolyte solution. So colligative properties. Colligative properties are those that depend on the concentration of particles in a solution, not upon the identity of those particles. So this is really cool because it doesn't matter what's dissolved, it just depends on how many particles of those things are dissolved. So boiling point elevation, if you put a bunch of stuff in water or some other liquid that doesn't boil, it will raise the boiling point of that. And this is the whole principle of candy making relies on boiling point elevation. Freezing point depression. Freezing point depression is the same idea. If you add a bunch of solute, the freezing point goes down and something does not freeze at the same temperature. This is what putting salt on ice does. And then there's osmotic pressure. So osmosis and transport through semi-permeable membranes of water is based on colligative properties. So freezing point depression, each mole of solute particles, and we keep saying solute particles, it lowers the freezing point of 1 kilogram of water by 1.86 degrees Celsius. The reason we say solute particles is because if it's sugar, each sugar molecule is one particle. But sodium chloride is NaCl. It breaks into its parts, and so for every mole of particles of sodium chloride, a mole of sodium chloride you put in, you actually get 2 moles of particles. So boiling point elevation, each mole of a non-volatile solute particles raises the boiling point of 1 kilogram of water by 0.51 degrees Celsius. So if you know how much you dissolve in how much water, you can calculate these. So if 15 moles of glucose are dissolved in 3 kilograms of water, what will the freezing point of this water be? What about the boiling point? I'd like you to list at least the 3 colligative properties that we talked about.